Hey, welcome back to this bonus lecture. So we said that appending rows is very inefficient in Pandas. Whether we're setting with enlargement using square brackets or even directly using the append method to add rows, each and every time we do one of these operations, the entire data frame is copied over in memory. And the reason for this has to do with how Pandas stores data in memory. Let me try to help you visualize this. The first thing we should note is that Pandas under the hood relies on NumPy and D arrays, which in turn rely on C arrays. C is a lower level programming language. So what happens is that our beautiful players data frame here is first split into chunks of homogeneous data types, right? Data of the same kind. So notice the output of our info method. All our columns are grouped or organized in three groups, in three chunks. Our player's data frame has 3 64-bit floating point columns, 9 64-bit integer columns, and 7 variable length object columns. These are chunked together and stored in contiguous blocks in memory. In other words, they're stored right next to each other. So this approach to structured memory is very much column-driven. We're grouping columns based on their data types, and then we're storing these chunks together in memory. Notice how there's no concept of a data frame row at this level. Every time we index a row in Pandas, Pandas needs to somehow reach back into memory, extract the relevant value from each block, and reconstruct a row object. And this is all orchestrated by what's known as the block manager class in Pandas. It's kind of an API between the Pandas representation of the data and the memory level constructs. So there's clearly a lot involved because the concept of a data frame row does not exist at this level, at the memory level. So now think about what happens when we append a row versus a column. When we add a column, Pandas first determines its type, right? It first figures out what is being added. Is it a float? Is it an integer? Is it an object? And then it identifies the block it should be added to based on that knowledge. And then it modifies that block only. The rest remain largely untouched, unchanged. When adding a row, however, we have to touch each and every block. All of them need to be copied, modified, and reassigned back to memory. And this needs to happen for every row that we append. This might not seem like a huge deal if we're working with a small data set and only inserting new rows once or twice, but as the size of the data frame increases, or the frequency of our insertions increases, I guarantee you that there will be a performance hit. So the big takeaway is that data frames should be seen as collections of columns, not rows. So if there's more than one way to address our use case, we should always try to avoid working on individual rows, because these operations will be slower for memory-related reasons. Okay. I hope this has shed some light on what we discussed in the previous lecture, on why setting with enlargement or even using append to add rows to a data frame is a very inefficient and slow process. Okay, thanks for watching.